All right, so what's the first law of thermodynamics? Give me the first law of thermodynamics. Energy can't be created, can't be destroyed. It's the law of conservation of energy. That's the first law of thermodynamics. Okay. What's the distinction between work and heat? Okay. Work and heat are both transfers of energy. What's different is what energy they transfer. Right. Mechanical goes with work. Thermal goes with heat. Right. Okay. Identify whether each of the following is best explained by the first or second law of thermodynamics. A bouncing ball eventually comes to rest on the floor. If it eventually comes to rest, it's losing what? Energy. Okay, which one of the laws talks about losing energy, or which direction energy goes? Second law. Okay, the second law says energy always travels away, okay, or is lost in an energy conversion, and that's what's happening. Every time the ball bounces, it makes noise. Every time the ball bounces, its shape changes a little bit. Okay, all of those represent losses of energy to the surroundings, okay, because that's an open system. Second law for that one. A metal spoon eventually becomes hot when placed in a pot of boiling water. Second law, yeah. Okay, energy flows from hot to cold. That's what's going on in that one. Energy cannot be created or destroyed. First. Okay. All right. For number 7, state the second law of thermodynamics. Well, we just talked about that for question number 4. Energy flows from hot to cold or high to low. Okay. Number 9. This is a trickier one. We've all seen this happen. Water is observed to condense on the outside of a cold glass. Which way is the heat flowing?
Hot to cold.
Hot to cold. Into the glass. Okay? When water condenses on the outside of the glass, it's going from a vapor, which is high energy, to a liquid, which is lower energy. And when it does that, it gives off energy. Okay? And so energy is going into the glass from the comparatively higher energy air that it is surrounded by. Okay? This is also why they tell you always be careful about steam. Steam burns you worse than water.
Yeah.
Okay? Because not only can steam be more than 100 degrees, and water can only obviously be 100 degrees, okay? But steam has also water that is changed from a liquid to a gas, and it takes a lot of energy to change steam or water from a liquid to a gas. And when the steam hits your skin, it condenses on your skin and releases all that energy. So it's not just that the steam could be 120 or 150 degrees, it also has all this other energy that is there because it's a vapor, and when it condenses, it releases all of that. That's the part that really burns you, okay? Not the 150 degrees. It's all this extra thermal energy, that's potential thermal energy or latent heat, okay, that gets released onto your flesh when that happens. So, okay, definitely heat is flowing from the surroundings to the glass in that case. Okay, which law of thermodynamics best describes the following statements? You can't get something for nothing. First law, you can't create energy. Okay, you can't even get close. Second law, yeah, you can't even get close to getting something for nothing because of the second law. Okay, and a rock will never suddenly jump into the air. First law, that would require you to create energy. Okay. All right, questions on any of those?
So like for the test, when it asks, like if it asks like what's the first law, we say like energy cannot be created or destroyed because like in the notes it said like total energy in a system and its surroundings remains constant.
Which is the same thing.
Yeah.
Yeah, energy can't be
So
created.
either
So
way
we
we
just
can-
phrase it shorter.
Okay.
Yeah, yeah. We're more succinct than they are.
Okay.
All right. Now we're going to move on to the more mechanical part. We've been talking about kind of thermodynamics and all of that kind of stuff. Now we're going to move into the more mechanical parts of this unit, okay? And that is scalars and vectors. Okay? There are essentially two types of measured values in physics. Measured values that have only a magnitude, that is, how big they are. And values that have a magnitude, how big they are, and a direction. Those are vector quantities. So if you've ever seen Despicable Me, okay, you know the villain Vector, okay, he has magnitude and direction, okay, it's true. Vectors do have magnitude and direction. They do not have piranha guns. I only know that because my kids were watching it yesterday and it's fresh in my mind, but it was fun. Okay, so you need to understand that there are many ways of measuring how far apart or how fast objects are going. We got to be able to differentiate between distance, displacement, speed, and velocity. Probably, right now, you think speed and velocity are the same thing, because that's kind of what we are taught in society. What you're going to learn today is society's messed up in a lot of ways, but mostly in terms of like physics stuff. Okay, the way we describe things is really, really wrong. For example, if I were to ask you how far it is to Edmonton, what would you say?
3 hours.
Exactly. What did you just tell me?
Time.
You told me how long it takes to get to Edmonton. What did I ask you?
How far?
I asked you how far. And even though not all of you said 3 hours, I would bet that almost all of you were thinking 3 hours, because that's how we think. Okay? When someone asks how far away is something, we tell them how long it will take to get there. What's the problem with that? Is that variable? Yes. Guys, I've driven to Edmonton lots of times. And it has taken me, I hate to admit, as little as 2 hours and 27 minutes, and as many as 9 hours. However, what has not changed on any of those trips is how far Edmonton is from here. The continent has not cracked open in the middle and had Edmonton get farther away. Now, I'm not saying that the city of Edmonton has not grown, and neither has Okotoks. That is certainly true. But from center to center, they are still the same distance away. Okay? And so when we say to someone, oh, Edmonton's 3 hours from here, we're wrong. It's not always 3 hours from here. That 3 hours depends on a lot of things. Mostly, how fast we can go. Okay? Mostly how fast we can go. And that is variable. There could be lots of traffic. I mean, sometimes you can get through Calgary in like 35 minutes. And sometimes it takes you an hour and a half. Okay? Well, suddenly I'm not getting to Edmonton in 3 hours. Okay? It makes a difference. My time is dependent on other things. But the distance from Edmonton to Okotoks is always the same. Okay? So we have to change our thinking a little bit, okay, around how we think about the way things are worded, okay, in our society. How far doesn't mean how long. How long means how long. Okay? How far means how far. Okay? So it's some stuff we got to get our heads around. All right, and then solve problems related to motion. So we are going to be doing a little bit of math, but don't worry, it's still easy. Okay? It's no harder than the mole equation yet. Okay? We're going to get to harder stuff, but the formulas we're going to use today are this formula, V equals d over t, and this formula. V equals d over t. I'm not, well, I'm a little crazy, but I'm not crazy here. That's different formulas. Okay? This formula tells me that speed equals distance divided by time. This formula tells me that velocity equals displacement divided by time. So, speed and velocity are two different things. Distance and displacement are two different things. Okay? Any quantity that has a little arrow over the top of it is a vector quantity. Anything that doesn't is scalar. Okay? So vector quantities, magnitude and direction, okay? And then our scalar quantities, just magnitude. All right, so obviously speed and distance are scalar quantities. So if I tell somebody how far something is, I won't tell them which direction. So if someone asks, how far is it to Edmonton? I would say 325 kilometers. Okay? What do I have to assume they're going to do?
Ask what direction.
Either ask what direction or just get on our very vast interconnected system of roads and find their way there. Okay? I mean, when it comes right down to it, the Highway 2 is fairly straight, but it's not perfectly straight. There are turns in it, okay, between Edmonton and Okotoks. So when I say it's 325 kilometers, I don't tell them what direction because I probably didn't follow a straight line to get there. Now, if someone asks me for the displacement between Okotoks and Edmonton, then I would have to give them a direction, and they would have to travel in a straight line, okay? Which is what you would do if you were flying from Okotoks to Edmonton in a helicopter, okay? Other than maybe having to go around the airport. I don't know if you have to go through their airspace. Whatever, simplify things. You can go in a straight line in a helicopter, okay? So I would tell them that it's probably only, 295 kilometers at, I don't know, probably 8 degrees east of north, okay? So you turn 8 degrees from north in an easterly direction and fly in a straight line and you'll get there, okay? Does everyone kind of follow me on that? Okay, so it's got magnitude and direction. Okay, if you get pulled over by the police and they ask you how fast you're going, do you want to answer which way? I'll say two ways. You tell me which way you want to answer. 130 kilometers per hour at 10 degrees south of west, or 130 kilometers an hour. Which way do you want to answer? The second one. Because if you answer the first one, you'll be doing a breathalyzer test right after. Okay? Because that is not the way normal people would answer that question. Okay? You give him magnitude and direction, and yeah, you're going to be in the back seat of the police car. Okay? Because that's just weird. And you're going to suspect something. Okay? So, there are times where you want to give a vector description of something, and there are times where you don't. Okay, there's times where a scalar description is appropriate, and there are times where it's not. Okay? All right, which one is time? Is time scalar or vector?
Scalar.
It is, it's scalar. We treat it like it's vector all the time. Okay? Lots of people, if I ask, how far is it to Edmonton, they go, it's 3 hours north of here. I didn't know time went north. Okay? Time doesn't go north. Time goes one direction, forward. Unless you have a time machine at home, and you know something I don't. In which case, you don't need to be in this class. You can invent a time machine, okay? You can just, go back in time and fix things, or whatever, okay? Time only goes forward. So time is a scalar quantity. We never assign direction to time. Okay. All right. Making sense so far? Okay, so as I was saying before with the how far is Edmonton from here thing, okay, the way we describe travel in everyday life is really only going to be effective at getting you hopelessly lost in a trackless environment. Okay, if you were ever in a place where you had to just find your way, okay, and somebody said, oh yeah, it's 3 hours from here, you're cooked. Okay, and I've had that happen. Okay, a buddy of mine and myself were backpacking a long time ago, probably before you were born, but okay, we were backpacking in Kootenay National Park, and we had this really long day. It was like 30 kilometers. We'd gone over 2 passes, and we thought we should be at our campground, but we weren't. And we were out of water, and we were hungry, and we're just sitting there kind of looking at the map, feeling sorry for ourselves, and kind of a bit frustrated. And this guy comes like bebopping up this hill. And it was no small hill. And he was literally running up the hill with a 50-pound pack, okay, and just trucking. And we're like, oh, sweet. We'll just ask this guy where Tumbling Falls Campground is. It's probably where he came from. We'll just ask him where it is. And he comes up to us, and we're like, hey, dude, do you know where Tumbling Falls Campground is? He's like, oh, yeah, mate. It's like 20 minutes down the hill. And we're like, oh, sweet, you're a lifesaver. And not really thinking, right? Because we're both physics teachers. That was the really embarrassing part of this. Right? Not really thinking. We're like, oh, sweet, it's only 20 minutes, right? We didn't notice the guy's in army fatigues. He's wearing probably didn't notice, but probably wearing special forces badges. He's just freaking running with his huge military pack on, okay, uphill towards us. We're two out-of-shape teachers on their summer vacation. An hour later, we are stumbling into the campground, exhausted, and we were going downhill. We are cursing this guy. 20 minutes, my butt. We're gonna find this guy. We're gonna go hunt him down after we get something to eat. And then we're like, after we got something to eat, got rehydrated, we're like, do you realize how dumb we are? We're physics teachers, and we let a person tell us how long it took him to get from one point to another, instead of telling us how far he went. That's what dehydration will do to you, okay? So you gotta make sure you're properly hydrated all the time. Okay, but that's what we do, right? We give people misinformation, not intentionally, but just because of the way we've been brought up. We can tell people how long it takes to get somewhere, and most of the time that's pretty true, and we don't have to tell them how, because they just get on the road and follow the signs. But if you're in an environment where there's no signs or less signage and not good paths and they're not well marked, you can get really lost with directions like that. Okay? If I just tell somebody, even if I tell them in meters, like I say, oh yeah, it's only 2,500 meters from here, and they're standing in the middle of a field with no trails, how many choices do they have for which direction to go? 360, right? 1 degree, 2 degrees, 3 degrees, right? You can get really lost, okay, in a situation like that. All right, so in this situation, let's say I'm here at Seldom Inn Campground, and I want to walk here to Snake Indian Falls Campground. All these little hash marks are trails. Okay? There's a sign outside of Snake Indian Falls Campground. Okay? It says, Seldom Inn Campground. And it says Snake Indian Falls Campground, 27 kilometers. Is that useful?
Yes.
Sure. It's perfectly appropriate to use a scalar description in that case because the sign makes an assumption, but it's a good assumption, that I'm going to do what? I'm going to take the path. Okay? And here's why that's a good assumption. To go in a straight line from Seldom Inn Campground to Snake Indian Falls Campground would require navigating see all these little squiggly lines? Those are rivers. Okay? There are canyons, because this is in the mountains where all those rivers are. Okay? And this gray stuff, that's glacier. Okay? Nobody is going to straight line this from one point to another on foot. Okay? In a helicopter, maybe, but not on foot. Okay? So it's a safe assumption, and then a scalar description of how far it is from one point to another is valid. Okay? But if I'm a pilot and I'm flying from one point to another, that is useless to me. I need compass directions, I need headings, okay, direction and magnitude if I'm going to get from one place to another. If I'm a cruise ship navigator, okay, same thing. Right? There's no roads in the ocean. I've got to get the ship pointed the right way and account for wind and ocean currents and make sure I get from A to B. That's going to require magnitude and direction. Right? So there's some cases where scalar is okay, and there's some cases where scalar is not okay. All right, so we say Calgary's 40 kilometers away, okay, from here. We make no reference to which direction Calgary is. We just get on the road because a scalar description of where Calgary is fine. We all know where it is, okay? And so we can just get on the road and find it, okay? But if we were needing a vector or if we were in a helicopter, we would need something else, like 40 kilometers at 13 degrees east of north, okay? Or something like that. Okay, which one's more accurate? Scalar or vector?
Vector.
That's our gut reaction, is that the vector is more accurate, but actually accuracy has nothing to do with whether something is scalar or vector. Accuracy has to do with how you measure something, right? So which of these numbers is more accurate? 40 kilometers or 40.1 kilometers? 40.1, okay? This number is accurate to plus or minus 1 kilometer. This one's accurate to plus or minus 100 meters, okay, or 0.1 kilometers. So your accuracy is dependent on how you measure, not whether you put a direction on it. I could easily say this, that Calgary is 4 times 10 to the 1 kilometers at 13 degrees east of north, and then say Calgary is 40.008 kilometers. That's a scalar description, but it's accurate to the nearest millimeter. Okay, whereas this one, sorry, meter, nearest meter. Okay, and this one is only accurate to plus or minus 10 kilometers. Okay, it's got a vector on it, but it's horribly measured. Okay, accurate to plus or minus 10 kilometers, I wouldn't trust the accuracy of anything measured like that. Okay, everyone kind of follow? All right, so here's what we're going to do. We're going to look at an example. Okay, I'm just going to redraw that whole diagram here. So this is scalar versus vector. So you might want to draw this diagram as well, kind of walk through it here. Okay, let's say I want to walk from my house to Home Depot. Okay, which is obviously in the southeast corner of town. Can I walk in a straight line from my house to Home Depot?
No.
Well, not unless I live right across the street, which I don't. Okay, so as long as I am living anywhere else in town other than right across the street from Home Depot, no, I cannot walk in a straight line to Home Depot. So let's say I come out of my house and I'm following the road that comes out of my house, and then I get on, Southridge Drive, and then I go to, Cimarron Boulevard or whatever it is, and take that over, and then eventually I get to Home Depot. Okay? Let's say when I'm done that, if I've been measuring my steps, that it ends up being 4 kilometers. Okay? Is that scalar or vector?
Scalar.
Scalar. Distance or displacement? Distance. Okay? So the distance is how far I have to go to get there. Is that how far Home Depot is from my house?
No.
Nope. Home Depot in a straight line is a lot closer than that. Okay? But I can't go straight there. I've got to follow the roads. I can't, just wade through the river or walk through trees and people's houses and walls and stuff like that. Okay? So I have to follow a logical path to get there. So in actual fact, all right, that line there represents my displacement from my house. Displacement is always how much you change your position and in what direction you change your position. Okay, so for this, this might only be 2.7 kilometers at 25 degrees south of east. Okay, because that would be southeast. Okay, but notice I said south of east, not southeast. What's the difference?
We go to east and then.
Yeah, so 25 degrees south of east is this direction. 25 degrees east of south is a different direction. That's why we never say northeast, southeast, or southwest in physics. We have to give actual compass coordinates. If we don't, if I just say 10 degrees southeast, that's two different directions. It could be east of south, it could be south of east, and those are two different directions. The only time I could accurately say southeast would be if I went at what angle? 45, right? Because 45 degrees would split that right down the middle. It'd be 45 degrees east of south and 45 degrees south of east. Then I could say southeast, okay? Because it'd be halfway in between east and south. Since that basically never happens, we won't do that, okay? All right, so this is my displacement. Okay, it's how far and in what direction I've gone in a straight line. That is how far I had to go in order to get there. Okay, now earlier we said that speed is distance divided by time. So let's say this takes me half an hour. Okay. How fast was I going? I walked 4 kilometers in a half an hour. How fast am I going?
Roughly like 6.5-ish minutes per kilometer.
8 kilometers per hour. I don't know what it would be in minutes, but yeah, okay, 8 kilometers per hour. So I went 4 kilometers divided by 0.5 hours, that gives me 8 kilometers per hour. I mean, logically speaking, if I kept walking, I'd have gone 8 kilometers in an hour. Okay? I went 4 kilometers in half an hour. Okay, we also talked about this. Velocity is displacement divided by time. So what's my velocity? Okay, that still takes me a half an hour. Okay, to displace myself from my house to Walmart still took me a half an hour. Regardless of how I got there, it took a half an hour. Right? So even though I only ended up 2.7 kilometers to 25 degrees south of east, so in a straight line from my house, okay, still took me a half an hour. So I'm looking at this being, sorry, not meters per second, kilometers per hour. Do I need to put a direction on that? Yes. What's the direction? 25 degrees south of east. Velocity and displacement always have the same vector because they're talking about the same trip. Okay, so if you've calculated it or have it for one, you have it for the other. Okay, so my displacement and my velocity are smaller numbers than their scalar counterparts, distance and speed. Will that always be true? Unless in this one situation. What's the one situation where they'll be equal? As long as, well, it's not necessarily 45 degrees if I went in a straight line. If I was actually able to do this trip in a straight line, then my distance and my displacement would have the same magnitude. Obviously the distance would not have the direction, but it would be 2.7 kilometers. Okay, everyone follow me there? So distance and speed will almost always be bigger than velocity and displacement unless your trip is actually a straight line. Okay, now I get to Home Depot because I'm getting old. I have forgotten both my phone and my wallet. I'm not going to walk around Home Depot for the fun of it. Okay, so I turn around and go straight back home. along exactly the same path. What's my total distance traveled? 8 kilometers, not a trick question. I know you guys probably thinking I was trying to trick you there, but no. Okay, if I go back home along exactly the same path, I will have walked 8 kilometers. The distance I will have traveled will be 8 kilometers. And if I get back and exactly an hour has passed, then I've walked at 8 kilometers per hour the entire trip. Everyone okay with that? Okay. What's my displacement when I get home? Remembering that displacement measures how much you've changed your position.
0.
0. When I get back to my house, my starting position, my house, and my ending position, my house, are the same place. I have technically accomplished nothing because I ended up back where I started. I may have walked 8 kilometers, but I did not displace myself from where I started. That's the difference between distance and displacement. Distance always gets bigger, but displacement is dependent on direction. If you backtrack, it can get smaller. Okay? In fact, it can go back to 0. Okay. Over the whole trip, now that I'm back at my house, what was my average velocity?
kilometers an hour.
No, that'd be my average speed.
Oh, okay.
We talked about that, right? Because that's scalar. Velocity is displacement over time. What did we say my displacement was when I got back to my house? Okay. Then what's my velocity if this number is 0? 0. Okay? If I haven't gone anywhere, I can't measure how fast I went nowhere. Does that make sense? I can't have a velocity if I technically didn't go anywhere. I didn't displace myself. There's no way to measure how fast I didn't displace myself. Yeah? You know, that seems kind of backwards, but okay, it's true.
What would the definition for velocity be in like this context? Because I think like how fast you're throwing a baseball or something like that.
Okay, that's speed.
Okay.
Right? Speed is the rate at which distance is covered.
Okay.
Velocity is the rate at which position is changed.
Oh.
Okay? And displacement is your change in position. Right? Okay. So, the little odometer in a car, okay? The thing that tells you how many kilometers are on your car. Does that measure distance or displacement? Distance. Okay? If it measured displacement, it would also have to say what direction. Okay? It would be nearly impossible for your odometer to measure displacement. Especially since every time you came home, it would read what number?
0.
No, it would read how far it is from the dealership you bought it at to your house. Every time you take it for an oil change, it'll read 0. Nobody ever answers that question right. I've asked it every time I've taught this lesson. I've never gotten that answer. Because everyone thinks 0. And you're right to think 0. You're seeing what I want you to see, but I have to mess with you just a little bit. Okay? So it would read, okay, every time I come home, yeah, it would come back to 0, which would be great if I was trying to sell it. Because I could have driven it around the world a whole bunch of times, and every time I come home, it'll say it's brand new. Okay? Well, that's exactly why it doesn't say that. Okay? It says how far you have driven it. You've driven it lots of different directions, okay? And it just keeps adding on. It always gets bigger. Okay? It never gets smaller. Right? Unless you had a really old car, you could put those in reverse and actually back them up. Okay? Or you could take the face off and just turn the analog dials back. Now it's all digital, so you can't commit fraud. Okay, so is everyone following here then the distance between, or sorry, the difference between distance and displacement?
Yes.
And speed and velocity. All right, so we've talked about that already. Okay, so, and we've talked about this. When we give the distance an object travels, we've used a scalar quantity. However, the displacement for the same trip could be different numbers, okay, but they would have a direction on them. So distance and displacement are different measures of the same thing, okay? They measure the same trip, house to Home Depot, okay? But they measure it from different points of view, okay? All right. And then speed and velocity, same idea. They measure how quickly you are doing something, okay? Speed, how fast are you covering distance? Velocity, how quickly are you changing your position which includes a direction, okay? Because position leads to displacement, they're vector quantities. Okay? And we talked about this, we traveled the same route home, then our displacement, our velocity would end up being 0 because our starting position and our ending position are the same place. All right. Algebra. We talked briefly about this back in the chemistry unit, but it's becoming a little bit more important now. Okay? How many rules are there in algebra? 3. Okay? There are 3 rules in algebra. Those 3 rules will get you through everything but calculus. Okay? They got me through university physics. Okay? 3 rules, but they didn't help me at all with calculus. I sucked at calculus. Okay? I only passed because I could memorize the examples in the textbook and write them down on my final exam and get part marks for method. I don't recommend that as a method for success. Okay? Luckily, I was in a class full of people who were even dumber than me. Okay? And it was graded on the curve. So I surfed the curve. Okay? It is possible in a class on the curve to fail and pass. Okay? 45, pass. Because a lot of people did worse than 45. Okay, so that's great when it's a hard course, you can surf the curve. It's an easy course, like psychology, okay? You get 89 and you barely pass. Because a lot of people got 95. Curve's tough. Okay. V equals d over t. So if I want to manipulate this, I don't want to use that. Triangle's bad. Very, very bad. Okay? We will not use triangles ever. Okay? Now, if I want to manipulate this equation right here and solve for d, what do I do?
U times d by t. Or t by t.
Well, yes, you're on the right track. I would multiply both sides by t. Right? Because if I do that, okay, I have a t on the top and a t on the bottom. They cancel. Okay? And then what I do to one side, I do to the other. That'll calculate d. Everybody all right with that? What if I want to get t by itself? This is the one we didn't have to do with the mole equation.
You have to divide both sides by t.
Okay, if I do that, and it's logical to think that because that would leave t by itself over here. But if I divide both sides by d, what's d divided by d? 1. That leaves me with 1 over t, which is not the same as t. Okay? 1 over t and t are the inverse of each other. If you said that 1 over t and t are the same thing, you're saying that 2 and 1/2 are the same thing. Are they the same thing?
No.
Please say no. Okay. All right. So I need to solve for things when they're on the top of an equation. I can't solve for something if it's on the bottom. So my best bet is to take t over here, just like we did a minute ago to solve for d, and then do what with v? Divide both sides by v. Okay, now I'm solving for t. T's on the top. Okay? All right. So, I don't think we wrote this down back in the chemistry unit, so we're going to write them down now. Or did we write down the 3 rules of algebra? Okay. These are the 3 rules of algebra. Write them down. Okay? They're really important. Then I'm going to show you how they apply to something tougher than v equals d over t. A formula we're going to use next week. Okay, so let's look at what these 3 rules look like in an equation that actually requires us to use all 3 rules. The mole equation in v equals d over t do not require us to use rule number 3. Okay, so I want to show you what it looks like if I have to use all 3 rules. So this formula here, you may already be looking at in math, okay, if you're taking math this semester. Y equals m times x plus b. This is the equation for a linear function on a graph, okay, or what we sometimes call the graphing equation. Okay? If I wanted to solve for x, okay, here's how I would do it. I actually would follow rule number 3 first. Okay? I'm solving for x. What's not attached to x? B. Okay? M is attached to x because it's being multiplied by x. They're right together, but there's a sign between these two, a plus sign. Okay? So B is not attached to x, so I would move it first. Now I go back to rule number 1. If I want to move something, I do the
Opposite.
okay. What's the opposite of adding?
Subtraction.
Okay, so I'm gonna, and then what I do to one side, I do to the other. We'll go over that equation in just a minute. Okay, so I'm gonna subtract b from both sides. So minus b, okay, y minus b equals m times x. All right, now all that's left is attached to x. So how do I move m?
Divide.
Divide both sides by m. All right, I just solve for x. Okay, is that very hard? As long as I remember, move what's not attached first, okay? And then the other two rules, do the opposite, what you do to one side, do to the other, you're set. Those 3 rules will not fail you. All right, so let's look at this one, okay? This is one we'll also use. So A equals, and I'll make that a little bit more obvious, okay? VF minus VI. Okay, so VF, VI divided by T and A. All right, let's say I want to solve for VF. Okay, what should I move first?
To the T.
T. T is not attached to VF. It is below it. Okay, so how do I move T over to the other side?
Multiply both sides by T.
Multiply both sides by T. I'm going to do the opposite. All right. So it cancels there. T comes over here. All right. I'm still trying to get VF by itself. So now what do?
You add VI.
Add VI to both sides, right? Because that's the opposite of subtract. So what I end up with is VF equals T times A plus VI. Okay? And it doesn't matter how crazy formulas get. These rules will always work. Okay? When you get to physics 20, this is one of the formulas you'll have to use. Okay? If I want to solve for L, I still follow all the same rules I would follow for this. Okay? I have a square root, which I would have to get rid of. So how do I get rid of a square root? Square everything, yeah, okay, that makes sure I get rid of the square root, okay, so I would do that to everything in the equation, or both sides. Okay, now the square root is gone. If I want to solve for L, what do I do with G? Multiply both sides by G, okay, I still want to get L by itself, what do I do with the 4 pi? Divide by it. Okay, the rules always work. It doesn't matter how crazy they get. And this is one that's like really crazy. And it's got plus or minus in it. But you have to decide whether the object and the observer are moving towards each other. That decides whether you use plus or minus. Okay? But it's still going to be no different. Okay? You're still going to move what's not attached first. You're still going to do the opposite operation to move things. You're still, all of that. I'm not going to make you do that. Okay? But okay, these are the types of formulas that you'll have to manipulate. Okay? You could get one like this. Still the same thing. If I want to solve for VI, I'd subtract that whole thing over to this side because it's not attached to VI. Okay, and then I divide by T. It doesn't change. The rules don't change regardless of how crazy the formula looks. Okay, the rules are always going to be the same. Okay, this is a V equals D over T question. Okay. It's asking how far will a deer running at 15 meters per second travel in 45 seconds? So, much like a mole equation question, the first thing I want to do is figure out what I have by writing down my givens. Okay, so how far, what part of this equation am I being asked to find? Distance. Okay, the deer is running at 15 meters per second. V or T? V, that's a rate of change of position, right? Meters divided by seconds, meters per second. So that's V. Okay, and it'll travel in 45 seconds, so that's T. All right, so you'd get a mark for that. Okay, for determining what your givens are. All right, so I have V, I have T, and I'm looking for D. Right? I know this is my formula. So if I want to get D by itself, what do I have to do with T? Multiply both sides by T. Okay, now I can plug in my numbers. D will equal 15 meters per second times 45 seconds. You wouldn't have to put the units in there. Sorry, I forgot to fire up the calculator in case Alright, so it would travel 675 meters in 45 seconds.
Do we have to write a sentence?
No, I generally don't make you write a sentence. Okay? Okay, so I'm done. That's my answer. So this would be 1, 2, 3, 4 marks. Something like that. Show me your givens, show me what formula, show me the manipulation, show me the answer. Okay, 4 marks for a question like that. Okay. All right. Try that one. See if you can calculate for me how long it'll take a tortoise to crawl 200 meters at a speed of 0.25 meters per second. Okay, so for this one, okay, looking for how long it takes, so what are we looking for? Time. Okay, crawling 200 meters. Distance. Okay, at a speed of 0.25 meters per second. All right, pretty obvious when they say at a speed of, okay, they're telling you the speed. All right, so I've got D and I've got V. I'm looking for T. So V equals D divided by T. I want to solve for T. I can't solve for something that's on the bottom of an equation, so I'm going to move T over to the other side. Now it's on the top of the equation, so I multiplied both sides by T. Now what do I have to do with V? Divide both sides, because right now I'm multiplying it. Alright, so T will equal D over V, okay, and that'll be 200 meters divided by 0.25 meters per second, which should be 800 seconds, right?
Yes.
Okay, 800 seconds, it's like what, almost 15 minutes?
Oh, no.
No,
Yeah.
sorry. Divided by 60.
13.
Yeah, almost 15 minutes, 13 minutes to go that far. It's a long time. You or I could walk 200 meters in probably about a minute and a half. Okay?
If you started doing somersaults, no, that'd be faster.
Yeah, it'd be faster. All right, is that making sense how that works? Okay, what if I gave you one that was like this instead? looking for the velocity of an elevator that goes 100 meters up in 20 seconds and then descends, so it goes down 60 meters in 15 seconds. Okay, so let's say this is where we start, on the ground. Okay, elevator goes up 100 meters. That takes 20 seconds. Then it comes down 60 meters in 15 seconds. And I want to find the velocity. Okay, so remember that velocity equals displacement divided by time. And my displacement is my change in position. So I started on the ground, went up 100, came down 60. What's my displacement? 40 meters. Which direction? Up. Yeah, my displacement over the course of this whole trip is 40 meters up. I went 100 meters up, minus 60 meters down is still 40 meters up. Okay, so my displacement is 40 meters. Okay, that's my total displacement. How long did that take? 35 seconds, right? 20 plus 15. So 1.1, we'll say. Meters per second up. Yeah, gotta have the direction on that, right? Calculating velocity, which is a vector quantity. Okay, this is something that could totally happen on a quiz. What's the total distance traveled by the elevator? 160 meters. Remember, distance is scalar. Doesn't care whether I went up or down, just how far did I go? Went 100 meters, then 60 meters, went 160 meters. Okay, what's the speed of the elevator? Speed is distance, which you just told me, divided by time. What's the time? 35 seconds. Okay, so my speed is a lot greater than my velocity because I backtracked. Okay? Anytime you backtrack, your velocity and your displacement are going to be a lot different than your distance and your speed. Okay? Everybody all right with that? That's a very common type of question to ask. Something goes forward and backward. Tell me the distance and displacement, speed and velocity. Okay? All right, no quiz tomorrow. Okay? You have a unit exam to study for. You're not going to have a quiz tomorrow. Okay? So make sure that you're studying for your unit exam, getting prepared for that. Reminder that you can come in here and start at 8:15 on Wednesday. Okay? So if you need to arrange for a ride, but you can start at 8:15 if you want to.
Mr. Codere,
Yeah.
will we have like a quiz on Friday since we don't have school on Thursday?
No quizzes this week.